Welcome to Spring LIB.
So the term oxidation means basically increase in the oxidation number of an atom or an ion in a chemical reaction. And the term oxidation is used because this type of reaction or the sort of these reactions that were first studied were the reactions involving oxygen. That's why it is called oxidation. But oxidation does not mean that in this type of reaction we have to have oxygen in the reaction. So, for example, if we look at an example of zinc reacting with hydrochloric acid, in this reaction, we will have zinc chloride will produce accompanied by hydrogen gas. So, as we have said that in an oxidation reaction, we will have an increase in the oxidation number of at least any of these atom or species or ion involved in this reaction. So if we look at the oxidation state of each atom or ion in both sides of the equation, we start with zinc, and as we know that in the in the elemental form, all the atoms have an oxidation state of 0. So zinc will have an oxidation state of 0. Then in the product side, where zinc chloride is formed, here zinc is an compound, in an ionic compound, where it has an oxidation state of +2. So here we can easily see that there is an increase in the oxidation state of zinc from 0 to +2, and that is the only condition for an oxidation reduction reaction. And that means this reaction is an oxidation reaction, and we can see that there is no oxygen involved in this reaction, and that proves that we can have oxidation reaction occurring without the presence of oxygen. So the first statement here is true, that oxidation can occur without oxygen. Now if we come to the second statement, where it said that oxidation can occur without reduction, so to test this statement we have to look at the other species here. So if we look at the oxidation number of the hydrogen and chlorine, we can see that hydrogen has an oxidation state of +1 here, and chlorine has -1. And in the product side, chlorine has again -1, but hydrogen this time has 0 since it is neutral molecular form. So here we can see that here is a decrease in the oxidation state of hydrogen, which is decreased from +1 to 0. So in any kind of oxidation reaction, there is an accompanying reduction in the oxidation state of another atom or ion, and that is called reduction. So that means that oxidation reduction reaction always occurs simultaneously. So if there is an oxidation, there will always be a reduction reaction also. So oxidation cannot occur without reduction, and that's why the statement B is false, that oxidation cannot occur without reduction.